We're going to get started. Thank you very much for coming. We have a three-person presentation. Of course, we tried to do something different today. And so we've got Noah in Sacramento, Noah Kelly, our design technology manager.
Hey, guys.
And we've got Francisco Penaloza, senior visualization artist, and myself. And our job today is to kind of show you the future of what we're calling a live model workflow in the digital environment. So our goal was to connect Rhino, Revit, and Unreal so that changes could be made in any one of these three separate programs, and it would all be a live update. This is a work in progress. This is not a final solution. You guys are going to see some under the hood stuff today that if you're not used to seeing the spaghetti of the visual programming that we're going to show today, it might look a little bit overwhelming, but that's okay. The goal eventually is, and what they're working toward, is making this as seamless as possible, and we're trying to stay ahead of that curve. And so really what you're seeing today is the latest way to connect all these things. And one of digital practice's goals is to eliminate waste between design and production documents. And what I mean by waste is remodeling stuff, all right? So while that isn't always going to be the case, and it isn't even always the appropriate solution, a lot of times it is appropriate to remodel stuff. We were just trying to push the limits of what we could do in what we're calling the live model workflow. So Francisco is obviously the visualization side. I am working on I'm representing the Revit side, and Noah is representing the Rhino side. And Francisco's working in Unreal, and then obviously I'm working in Revit, and Noah's working in Rhino. You can kind of see what Francisco's working on here in the upper left-hand corner. You can see what Noah's working on in the upper right-hand corner, and you can see what I've got in the lower left-hand corner. And we're using a web app to kind of all work together at the same time so we can all see what each other are doing. And we're using this also as our presentation tool today. So the other offices that are piped in are looking at this, and it's just playing in a web browser. So there's no Skype for business crappiness going on. We're just looking at this over the web, which is also kind of pushing the limits of what we can do. And what's also kind of neat, just on a side note about this web application, is there's a specific Rhino plugin where you can actually push exactly what's happening in your Rhino model out, and other people can control it. So if you wanted somebody else to take over the inputs, they could actually do that through Rhino right over the web. It's pretty crazy. So anyway, this is all new, and like I said, we're kind of pushing the limits. So what Francisco is going to do is start off and show you kind of the end product, and then we're going to take you back and show you how we got there. All right?
So as Evan already made the introduction, so the idea is usually in HMC, the way they work is designers start with their schematic, the basic modeling and massing of the building, right? And let's say we are in a competition where the deadline is very tight. So then we have to wait for that is done to go to Revit to do some elevations, sections, and all the good stuff that you can do in Revit. And then that is sent to the visualization team, and then we start to doing still renderings, animations, or VR. So if in any time there is a change on the design, which usually happens, everything has to be done again. So our idea, our concept is how we can make it that everybody start to work almost at the same time. So at the same time that, let's say, Noah is designing his building, he's not sure if it's going to be a straight or if it's going to be a curve, already sent to somebody that is in Revit and can be already put in the elevations and the sections. Oh, this is what we will need, doing some layout, coloring, and all that. And at the same time, it's already sent to the visualization team so we can start working in landscaping and make it just pretty. And then we can plan, oh, we need a video, we need still images, or we need just a VR presentation. So in this case, well, you guys couldn't see, but one of the final output was a video, and it's not playing correctly, but just eye candy of moments of this building that is not fully developed, but I already can have an animation and see how it's gonna look, right? And this model here, for some reason, my screen is showing with a nighttime. But I would like you guys to take a look at the size of the fins. That they are very small right now, and they are not working well with the design. So later on, Noah will do that change in Rhino, and we're gonna send it to Revit, and from Revit it's gonna be sent back to this Unreal file, and you guys will see how everything is connected throughout the presentation and will be connected throughout the projects. So you can see that over here, can I show you now or later?
It's up to you.
Well, we can see that.
Yeah, go ahead.
And in this moment, while the design is still a work in progress, I already built the whole site of this project, and I can extend it, with the city. We can see some serious landscaping. This is the way that it is actually the site right now, with hundreds of thousands of trees, and I can go really.
It's not updating as fast as you're talking.
Okay, so I can go really granular. 1 second.
You guys can probably hear Francisco's fan cranking up here.
Yeah.
Computer's thinking really hard.
So why? Well,
it's very
there
dark.
is grass over there. So I can go to a pebble, or I can go to the greatest scale of the whole city. So stepping ahead of what I was preparing to say, but why Unreal? And some of you might be asking why you are not using Lumion or Enscape. And the main difference between this tool, Unreal, with Enscape and Lumion and Enscape are what we call it a push button tool. Very easy to have something quick, not spending time, not thinking about it, just give me the image, I'm happy with that. A difference with Unreal, we can create custom experience. We can go beyond that. I can show you later on in the presentation. I set up some, I can change the design in real time. I can change colors, or I can change the whole building if I wanted to. And all that can be delivered to the client, so the client can experience on his time the presentation. It's not just what Lumion will give you, what Enscape will give you. So that's pretty much. So,
yeah, so now Noah, we're going to jump over to Noah's screen, and Noah is going to show us the building and what he's going to make a design change to the building and send that information over to Francisco. So you guys saw on Francisco's screen there were very thin overhangs and not very many vertical sunshades. And so now Noah's going to kind of take us into the building and make some updates to it.
Yeah, so like I said, the design of this building is pretty poor. A lot of sun getting in there. So we're wanting to kind of extend those floor plates and then create some more vertical fins. So we're going to use, this is a building just completely driven by Grasshopper. So we're going to use this Grasshopper definition that I wrote that hasn't been totally cleaned up, but to make those adjustments. So I'm going to offset the floor plates a little bit more to 6 feet. So you can see that starts to adjust back here in the background. And then I'm going to add more fins by reducing the spacing as well down to 6 feet. And so now you can see this building has a larger overhang and more fin spacing. So if I want to update that in Revit, all I have to do is come over here, click, and it's going to update my building. The reason for that is because of a new new tool developed by McNeil, who's the developer for Rhino. They're separating the Rhino API so that it can run essentially in any program. They call it Rhino Inside. And so the use case that we're using is running Rhino inside of Revit. So you can see here that Rhino is actually an add-in in Revit. So you launch Rhino from Revit and model there. And so that allows you to update your building using your Rhino geometry. And it's also all native geometry. So you see I can click here. That's a floor generic. I can edit that type, that structure, and add what I would like to add. And the nice things is when you make changes to the properties of these native Revit geometry, if you modify the form of the building, those properties are going to remain, which is nice. So I'm going to sync my building like we all know how to do. And then once it's done syncing, Francisco is going to sync as well, and then export it into Unreal while we continue to talk about the process that we've gone through.
So just to kind of reiterate, Rhino can run in many different applications theoretically now. You could run Rhino inside of Photoshop. You could run it inside of other 3D modeling applications, other rendering applications. So what they've done is they've completely separated it and made it available to any developer who's willing to kind of take that on and plug it into their application. This has huge implications for us. And luckily, we have people inside, the people who make Rhino, actively developing to put it inside of Revit. So this is a huge, huge deal for us because it's not like, right now, if we build a model in SketchUp or we build a model in Rhino, we could export that model and we could import it into Revit and see it. But these are actual Revit elements. So section cuts work right, we can tag stuff, we can dimension stuff. It updates whenever we update that model. So this is a very big deal for the future of our workflow because we won't have to remodel things or do that whole export-import dance and wonder if we have the latest model or if it's 2 versions old or whatever, because we're actually building it all right inside of Revit, but we're using a really advanced plugin for Revit now called Rhino. So Noah flexed the build, he adjusted the overhangs and the fin spacing, and as soon as he synchronizes that model, now Francisco has access to it. And now Francisco is synchronizing his model to get those latest updates, and he's going to push those through to Unreal. So while that's happening, because that is not an instant thing, there's a lot of geometry, there's a lot of stuff going back and forth. Noah's going to take us kind of through the process of how we got these forms, and he's going to show you some of the scripting that it took for us to build this. And this is, our kind of idea for this is obviously this is not an HMC building. We're kind of approaching this from like a competition standpoint of you can't work, forever on a competition. You've got very limited resources when it comes to time and staff. And so how could we set it up a way so that all 3 of us could be working together in completely different things, but on the most recent information. So I don't have to wait for Noah to finish the model before I can start documenting it in Revit. Francisco doesn't Revit right before he starts rendering it because it's all happening at the same time. So instead of working in series, we're working in parallel. So Noah's now going to take you kind of just to how he's generating the form of the building and then talk about how we got that site context and everything through scripting inside of Rhino.
Yeah, so we can start with the site context. And so to get this information, I used a Grasshopper plugin by the name of Elk. And I just grabbed the USGS topo file from the USGS site. And then the OpenStreetMap file, which gives you all the information about streets and buildings, building heights, whatnot. And so that allowed me to generate this model that you see here on the left. And so You get a really accurate topo site and a really accurate building model depending on how much data the city collects. Usually a site model this large is more for general context, so you can always fake it if you need to by having a randomly generated building heights as well if the city doesn't collect that information.
And just so you guys know, this is Portland, so this is actual terrain data, actual building outlines. Like, no, we didn't build this out of looking at stuff on Google Earth. This is all driven by these algorithms.
Correct.
So it's all as accurate as the information that's publicly available. But we had to spend very little time to make this model. It was all based on data that's out there.
Correct. And if I wanted, now that I have this script set up, if I wanted to go and model Sacramento, San Francisco, I could just grab the files, load them into the script, and I'd have a site model instantly. Well, within a few seconds. So it's pretty cool, pretty handy, really helps boost efficiency. So we can now look at the building file. So the building files, like I said earlier, it's a parametric building. So everything in here is driven from the script.
So the model that Noah has built here, it has a lot of different components in it. So it's got fins, it's got soffits, it's got floors, it's got all the different components that are necessary to make it look like a building. Again, we're kind of thinking of this from like a competition phase of a project. We're talking about overall form and probably some area that the building would need to fulfill, and then some overall facade ideas. So this isn't generating every possible component. The script was not really designed to do that, but this is something that it's really interesting that it's generating all of this stuff, and Noah's going to show kind of the punchline to this in a minute. The entire building is based on a single line, and all we have to do is adjust the single line and everything on the building updates. And then there's further parameters we can control, like sunshade spacing and floor-to-floor height and all of those kinds of things. And so right now you can see, yeah, this is a conceptual building, but these are the kinds of things that we can hook up to real projects as well, so that we can get something that looks real and allows us to do daylight testing and allows us to do environmental analysis very quickly with these tools, because once these scripts are developed, we can reuse them over and over again. So on the right, you're looking at what's called a visual programming interface, and that is Grasshopper in this case. Revit has one as well called Dynamo. But what it allows you to do is string together these components in different orders to basically write a program, but without typing a line of code. So for those of you who have never seen this before, it looks like a total disaster, and it is. It's a total disaster. But with the scripts that we release to everybody in the firm, we spend quite a bit of time going through and organizing the scripts and commenting it so that people who do want to run them know what to do with them, and it doesn't look like this. It's a lot more presentable and approachable. But if you need to get under the hood and tweak something, that's when we actually get into the spaghetti that's back there.
All right, is that better?
Yeah, way better.
All right. So like Evan said, this is all driven just off of a single polyline that lives right here. So if I wanted to, I could take the point of this polyline, drag it, and the building is going to automatically regenerate to whatever shape I would like. Currently, it's best to use just polylines, not any curved line. Just translation into Revit is a lot more difficult when you start adding curves. But yeah, so as you can see, I mean, I can pretty much adjust this line and the building follows. So it's really helpful when you do have like a large building and you're trying to mass it out. You can just drag that polyline into the the desired shape and location, and this script is going to just automatically generate that building for you, as long as you don't make it too big, which I might have done. And as you can see, scripts can be broken as well. So, but that's to be expected. Not every script is going to be perfect. Yeah, so that's pretty much the script and what it does. It also locates columns.
And what this allows a designer to do is play with lots of options very quickly, right? Like that's really where we could try different building widths, different floor-to-floor heights, different layouts on a site very, very quickly. Whereas before you were modeling all this stuff by hand, each building at a time, and then when you got a design to do a design change, you got to remodel all that stuff. So we're working as diligently as possible to make it so that the algorithm builds the geometry for you, so that you don't have to build all those pieces brute force every single time.
So Evan, do you want to show them how the work sessions also work?
I think we probably have time to do that. So what I've got here on my screen is I have the local site, and I also have the topo of the whole thing linked in. And one of the things that we've had the ability to do in Revit for years is have multiple people working in the same file at the same time, which is called work sharing, right? So Rhino has a similar technology where we can have what's called a work session. And we have 3 work sessions in here right now, but they're all linked together. So multiple people aren't working in the same file at the same time, but we all can be aware of what each other are doing. So if Noah's working on the building, that can be linked into the localized site. And here you can see like a low-res version of that in there. And then we also have a localized site where we're doing more site design. And then we have the overall large topography model. And so I can go in and manage my work sessions so that I can turn them off or on, but I can also see what everybody's latest model is. And what's really cool about it is I can actually grab stuff out of their model and copy and paste it right into my model without ever opening their file. So I can theoretically, you know, if I'm working on hardscape and Noah's working on the building, he could grab a piece of my hardscape out and put it into his model so that he could build something off of it if he wanted to. So like right now, I'm gonna just detach the site model. And again, our computers are working real hard up here because we're all pushing this out over the internet and screen recording at the same time. But it gives us the ability to have multiple people, and actually this is happening on our Glendale project up in Ontario 3, where we have our building designer in Ontario, that's Miguel, and we have Emmanuel in our Oakland office, and he's working on the site and the topography, but they can see what each other are doing at all times in Rhino. So the functionality of that is pretty cool. So the question was Dynamo versus Grasshopper, and why would you use which one when, or is it preference, or what are they good at? So Dynamo is built into Revit, and Grasshopper is built into Rhino. So right there, you're kind of deciding what software platform you're going to be using for whatever specific purpose. But now that we can run Rhino inside of Revit, that's where this question really comes from. And Dynamo exposes all of Revit's parameters, and Grasshopper exposes all of Rhino's parameters, and they're not the same thing, right? Revit is BIM. It's an example of BIM, and Rhino is whatever you want kind of a modeler, right? So you're not dealing with walls and floors and columns. You're dealing with geometry. So Dynamo is really specific to Revit. It grabs things out of Revit and pushes things back into Revit. And Revit has always been a documentation tool, right? Rhino is a geometry tool. And so now we've put a really world-class geometry tool inside of a world-class documentation tool. And so I kind of think we have the best of both worlds. And the thing is like Grasshopper and Dynamo talk to each other too. So we're just starting to scratch the surface of what's possible. But what's really cool is we're going to be able to grab specific parameters out of Revit and put them into Rhino. And Grasshopper's been around a lot longer than Dynamo, so it does a lot more. And we're going to be able to kind of exchange data really fluidly. And I don't think any of us kind of understand what that really means yet. At the lowest level, it means exchanging geometry. But it could be extremely complicated beyond that. I know it doesn't fully answer your question, but there's been lots of plugins developed for Grasshopper over the years, and it's not so. There are lots of plugins for Dynamo too, but nothing near what there is for Grasshopper. So now we have access to those inside of Revit. So there's lots of intricacies to that answer. I mean, it could go a lot of different directions. Materials. So at this time, there have been several components written for Grasshopper that are specific for those elements in Revit. So if I draw a line in Rhino, I can tell it to make that a wall in Revit by specifically telling it that's going to be a wall. And there isn't an option for everything, but there's walls, there's floors, there's columns, there's like the basic building blocks. Beyond that, we can just send pure geometry over. And that geometry Revit sees as kind of like a mass in place almost, but it's real Revit geometry at that point. Thank you for killing time. I just was going to show you guys real quick here. Like what I've got is I've got a script in Grasshopper. I've got a Rhino model of my localized site plan here. And all of this information that you're seeing here, kind of like Noah's building, is just being generated by lines and parameters. And so, like, for instance, if I go to my top view, you can see that I've got, can you see it? Yeah, you can see my sidewalks here, right? And then I have these kind of nodes at the end of the sidewalk. And so if I click on this line and I update, the shape of that sidewalk just by adjusting that line, it rebuilds all the geometry based on that. So it's automatically building the sidewalk width, it's building its depth, and if I go over here into Grasshopper itself, I can go into my, if I can find it, like I said, this is pretty crazy. It's down here. I can actually control like my grove of trees. I can control my sidewalk width right now, like it's set at 6. If I set my sidewalk to 4, you'll see that it'll thin up over here and turn into a 4-foot wide sidewalk instead of a 6-foot wide sidewalk. And if I'm just running this by myself and I'm not pushing it out over the internet, it's real fast. Okay. Now the cool thing about that is I'm actually changing that in Revit as well, because I'm running Rhino inside of Revit. So you can see I have a 4-foot wide sidewalk inside of Revit, and if I click on that, it's a Revit element. So if I come back into this Grasshopper definition and change this back to, let's go to 8 feet and hit enter. And if you watch in Revit, it will actually just update that geometry right over there. So I could change this, anything about that. And what's really cool is that sidewalk is following the topography. So I don't even have to go in and do all the adjustments. It's just because of the script, the way that I wrote it, it automatically follows the topography on the site. So it's saving a ton of time because sidewalks change, right? If I go to my my amphitheater here, same thing. I'm deriving amphitheater steps by just saying, here's a line there and there's a line there, and build all this geometry between them. And if I come over here, I can say, how many divisions do I want? There's so many things that I could do to change this up, and it will rebuild them based on these different factors. And again, those are going to automatically show up inside of Revit and just update when the design changes, because it always changes.
I do want to show overall building updates in Revit, because we showed the floor plate and we showed the fins, but what we didn't show is the whole entire building updating. So I have my model open running inside of Revit. And like I did before, I can grab this same polyline. If I move this polyline over, the building is going to update in my Rhino environment. When I click over here, it's also going to update in Revit. So it's going to take a little bit longer now because I'm updating the whole entire building, but not that long. And it regenerates everything with native Revit geometry, just like before. So it's really handy when you're making those changes and you're wanting somebody to also be in the model, able to set up views and set up sheets. You can do all of that concurrently.
Yeah, so, and I'll do that real quick, because I'm also working inside the synchronized Revit model here. I can look at my floor plans. I could be setting up these views to be whatever I need them to be. I can look at my site plan, and I've got shadows turned on, and I've got all my elements, and they're always the most recent elements from the Rhino model. I'll make it a little bigger here so that you can see it. So here's my site plan. I've got floor plans. I've got elevations. And those are all being generated from that Rhino model. But again, these are all native Revit elements. So even the trees, like these tree locations, we placed the trees in XYZ coordinates in Grasshopper. So I could adjust the number of trees, the spacing of the trees, the height of the trees, whatever. And that information is getting pushed through all the way to Francisco's model in the Unreal environment.
So I can show the previous model, the live link is still updating. And it's taking longer because, like Evan was saying, we are dealing with 3 different software, but the purpose of the software are different, right? So this Rhino is very strong in modeling anything that you wanted to, Revit, beam information and beyond, right? And Unreal came, for people that is not aware of it, came from a gaming background. This software was developed to create video games. So any games like Fortnite design in Unreal, Diablo design in Unreal, any game, famous game, are all, most of them designed in this type of platform. And why? Because it can scale, can create a phone apps, or also can create a large AAA games. And that's where we see as a HMC, as a company, we see the strength and start using this type of software so we can do whatever we wanted to. So as Evan mentioned it in NOAA too, so NOAA took that survey data for the site, and that data is the same data that I took here to create this site in Unreal. So again, the location of all those buildings and everything is through that survey data. Then, the capacity of Unreal, I can put thousands of millions of trees and grass, and everything will be there. So if Evan does any change in Rhino, the location of those plants or bushes, they will translate all the way through to the visualization team. So I just concentrated and make it look nice. The design is no part of my deal. It will happen. And so when all that is said and done, we can get an animation like you tried to show at the beginning, but we also, this model can be a VR experience for the client. In a VR experience, we can enrich not only making it look nice, but with some custom design, which, for instance, Lumion or Escape cannot do. In this case, I can change the time of the day as needed, right? You can see how the sky is changing, or you can put the shadows And in this case, we can show design variations. So in this case, I am not right now running on the software. This will be the actual presentation for the client. So I can turn on and turn off the things so we can show design variations. Or I can change the whole building if I wanted to. And also we can do real-time material change. So in this case,
Yes.
anything can happen, right? So we have a spaceship over there. We can have some wood things going on. Or we can have
He did not curate these through me.
yeah. Coming from the gaming background, we need some glowing something. So we have that sort of weight design there on the building, which looks really cool. Much better now than before.
Talk to Noah.
Looks great.
So all that, it cannot be done for a point and click tool as we use, but it can be designed. And like I said, with this type of tool, the sky is the limit. We can do whatever we wanted to. And at the same time, I'm connected to Revit. So any change, we translate here. In this case, you didn't see any materials in Revit. And Revit assign a basic material. But over here, I can write some code since Noah and Evan, they've been showing their spaghetti noodles.
It's all about code.
It's all about code. I have my own codes too. So, so this is the difference of point and click tool and a tool that you can
Getting a lag all of a sudden.
Yeah.
It was working well in many of it.
Yeah, we can flex it the way that we really need to. And that's the main advantage. So in this case, I can control the material as I need it. And I can even write those parameters to let the person who is playing the game or having the experience to change it too, if I wanted to. So we can let the client to choose his own color. We can tell it, choose out of this one or choose your own color. Everything can be programmed and let the client do whatever he wants. So that's the main advantage of this tool compared to any other. And
We're still waiting.
I think it's already done. It's just how to save it.
Okay.
But so that's pretty much. And of course, we can get still renderings, if we need it for our competition presentation. I sort of preset some cameras here to show, the whole extent of the project, and some detailed shot. They can be shots of the project.
And you can see the trees are blowing in the wind. And
Yeah.
when he was in the forest with all the thousands of trees, all the trees are moving and the grass is moving.
So for instance, that's one of my favorite shots.
Can you change the seasons?
Yes. Not right now, but yes.
If you tell him early enough
Yes.
in the process. So it's pretty cool. I mean, even with what seems like a still image, just adding a little bit of this life to it really makes a big impact and makes it feel so much more real.
So right now, I think it did it.
Yeah, so this is the building with the updates that Noah did in Revit. So now we have more fins, and they're deeper, and the overhangs are bigger.
So at the beginning of the presentation, this model was with the shorter fin, and then Noah did all those changes that translate to Rhino, and finally finally the export to Unreal, and over here I can have the control of my model.
And the reason why it's new is because of the
I think so.
Yeah, the connection, and also since Unreal is a gaming engine, it's have to optimize the geometry and do a lot of background.
Has to calculate all the reflections and
Yeah,
everything,
and
so that
everything.
as soon as it goes live, everything's live, like for real live, and you can walk through it and it looks good.
So for instance, right now, now that I have these new things, I have my code already. Like Evan said, everything is so this is a little script that I wrote that right now is represented as a node, so I can reuse it to do anything else, not only in this project. So I have my these are the different materials that I did preset, and now I just plug in the new things that came from Rhino. I compile in my file, and now when I run in my presentation, I can do exactly the same, tune it on, tune it off, and I can change the material to the spaceship and what
My favorite.
the glowing stuff. So any work that I did ahead of time is not lost. You just update the link, and we are ready to go.
So in the future, we could see the integration going a lot deeper and having a lot more control over the different, every little element that Revit has from Grasshopper and Revit or Rhino. So there's quite a bit of work still to be done. Like this just came out a few weeks ago. This is all real new stuff. There have previously been other ways to link Rhino and Revit together, but none of them as kind of deeply done as this has. So it's pretty amazing stuff. And we're happy to have the smartest guys here who deal with this stuff all the time, helping make it a reality, because this really is the direction that this is all going. So if you guys have questions, we'd be happy to spend the next few minutes talking about that. And no, so the question was, does Rhino need Revit to get to Unreal? And no, Unreal will read any FBX file out of anything. But this live linking is accomplished with an extra piece of software called Datasmith that is sending the Revit model over to Unreal. Francisco could probably elaborate on that more than I can.
Yeah. So Unreal about 3 years ago I started working seriously to create. They saw that more people than myself were interested in using a real-time tool to produce visualizations. So transforming Revit files to a game engine is a pain in the neck. It's really hard. I know that sometimes I talk to some people, some other architects, and they say, "Oh, so I should learn Unreal." My answer is, there is no way for you. You won't have anything useful spending your life trying to learn in this software, because it's only good for this, right? It won't help you to design better. For design better, you have answers. You can have Lumen, because it's one click. Don't worry about it. It's somebody that doesn't have a soul like myself. I want to spend my life trying to figure out how this software any kind of makes sense. So that's why they create that. What it does is all the work that I do manually. Right now, the software does by itself, and that's why it takes some time to translate everything. For me, it couldn't be a day of work. Right now, it can be a couple of hours or a couple of minutes. That will depend on the software. Datasmith is creating plugins for all the CAD tools. So from Archicad, MicroStation, Revit, SketchUp. Most everything right now can be imported directly to Unreal, and then work from there.
You tag on a lot of different programs, but does the workflow still stay the same? So as long as your materials are labeled the same, whenever you update a model, you can run with that, right? So you can
Basically, you can break out all and not anything. Like, there's more prefer you can break out all a site model and then break model and you can have this test.
Correct. So the site, the site for me came straight from Rhino, and the building came from Revit, and the closed site came from Rhino into Revit and then into Unreal. So the main point for me, for you guys to take away here is like even though it's cool for one person to do everything, it's not optimum because then you still have to do something to start doing the next step, right? But since in HMC we have so many talented people knowing different stuff, what we are trying to figure out is how we can all work together at the same time in a fast, speed environment. And that's where you will have the strength we use. Then you can use Unreal at 100% because you have somebody that knows Angular. You can use Rhino at 100% because you have somebody that knows Rhino and so on and so forth. So to answer your question, yes. From SketchUp to Unreal, also from Rhino, it can work.
So is there a limit to how many people can be on Revit at a time? Can the whole team be on Revit? One person can be doing this, or two people?
Yeah, so the question, I'll just repeat it, was, is there a limit to how many people can be in Revit? It's the same as normal, it's normal Revit. So no limitation there beyond like what we already normally do. In the Rhino file, you can't have multiple people in the same file, but you can have people working on it. You can break up the file and everybody can see what each other's doing. And then Unreal, it's just one person, right?
No.
Oh, it can? Oh yeah, that's right, because you can have people working on you could have different levels of the game that people could be working on. Yeah. So the question was, does all the modeling have to be done in Rhino? So at any point you could break the process to just go from Revit, right? But if you're going to be moving walls around and driving the form of the building, you're always going to be going back. If you're going to do something that big of a change, you're going to go back and do it again in Rhino and then update the model in Revit. So, just like our design process, at some point, you're going to use Revit at what Revit's really good at, and you're going to stop going back to Rhino. But just know that like you see the building model in Revit, right now you could stop using Rhino and just continue in Revit, right? But that model is live in Revit, it's Revit geometry, if you move it in Revit, it does not move it in Rhino. Okay, so it's a one-way street, not a two-way street.
But you can also still make changes. Like if you look at Rhino currently, I didn't model the storefront. That is coming from Revit.
Yeah, it's just a surface in Rhino, but in Revit, we're telling it to become a curtain wall. And so in Revit, you could adjust the curtain wall parameters and it's not going to change what's happening back in Rhino.
Unreal.
So yeah, the question is, has there been thought put toward material mapping for different rendering outputs, or who's doing it? So our goal, one of Digital Practice's goals this year is to define a material library that's useful everywhere. So it'll be the same materials. You could use it in SketchUp, you could use it in Rhino, you could use it in Revit, and you can use them in Enscape. And then Unreal uses a completely different you can use a completely different material engine, which is way better. But the beauty is, if we intentionally create all of our materials, which really is not that many materials, right? It's like the basics, and then there's a few weird ones beyond that. Francisco can have it on the Unreal side for it to auto-translate to the best and the greatest materials, while we might just use the ones that are good enough in Enscape. The goal is to have it so you can do your texture mapping, and we want to really raise the level of our texture mapping in Revit so that we can do material tagging correctly and have it show up in Enscape appropriately. So between Noah on the Rhino side and Max on the Revit side and Francisco on the Unreal and 3D Studio side, we should have a unified material library this year so that everybody's using the same stuff. Knock on laminate. And that ties into our new content management system that we're developing right now, and so everybody will have access to what we call that single source of truth of where to get everything. So everybody will be grabbing the same stuff.
We also have some questions online. So one of the questions from the Oakland studio is, does Revit automatically recognize walls, floors, roofs, etc., or is that a setting that will need to be scripted in Grasshopper. So an answer to that is it's a Grasshopper component. So when you're in Grasshopper, specifically Rhino Inside, you have a new Revit tab, and that has all your Revit components. So you can see here that this group is what's pushing the Revit columns into Revit, and this group is what's pushing the Revit walls. So that will need to be scripted for now. And then there's some questions about where we assign materials, and can it read materials from Rhino or Revit?
So you can talk about the Rhino part, but Unreal definitely will read materials from Revit.
And I will say that I don't believe currently that the Rhino materials are going to push into Unreal. But Francisco, correct me if I'm wrong, but I believe it will push into Unreal from Rhino.
Yeah. If it's a direct connection from Rhino to Unreal, it will read the material, or from Revit to Unreal, it will read the material. So then I have the choice to keep it, or like it said, Evan mentioned it, I can enhance with something else, like mind-blowing.
Way better stuff, like video game technology. Well, thanks for coming, everybody. We're right on time, and we appreciate you coming and seeing this.